And here's the math they go through to do that. So they decided ahead of time what they want their margin of error to be and what they want their confidence level to be. So remember, recall, I just wrote it up there, the margin of error is some Z star times the standard error, and the standard error is square root of P hat Q hat over N. So we want the margin of error to be less than or equal to 3% or 0.03. So we're just going to solve this for N. Problem is we don't know P hat and Q hat. If we knew those, we'd already do the sample. So maybe if we've done samples in the past and we got a good idea what these two numbers are going to be, we could use that. But if we're starting a brand new sample, we don't know P hat and Q hat. So we do worst case scenario. What numbers would be here that would make the margin of error the biggest it could possibly be? And those would be 50-50. So the worst case would be if both of these are 0.5. Anything less than that, if P hat is bigger than 0.5, then Q would be less. Anything different than 50-50, support, whatever, would make the margin of error smaller. So we're just looking at worst case scenario. So then that means we're trying to solve Z star 0.5 times 0.5, all under the square root here over N, is less than or equal to 0.03. Now Z star, what's our confidence level? 95%. So that's in our table. Again, you don't have to have that memorized. I've just done this so long. I know that one. I can never remember the one for 99%. Those are in that document. Make sure you wrote them down in your notes. But this is the one for 95%. So I'm trying to solve 1.96 square root of 0.5 times 0.5 over N less than or equal to 0.03. So this is really just an algebra problem. And to be honest, this is the hardest algebra problem we do all semester long. Now I'm going to do this in general. So I'm not going to like multiply anything out yet. I just want to type everything in at the calculator at the end. And I'm also going to get a formula that you can then just use when you have a homework problem that's similar to this, but it doesn't use 3%. It uses 4% or 2%. It uses a different number here. So you'll be able to just use my final answer and just change that. So how would we solve this? First, I would want to get rid of that 1.96. So divide it over. Now, how do I get rid of a square root? I square both sides. Everybody's positive, so I don't have to worry about flipping over this radical or anything. So the square root and the square, those will cancel each other out. Okay, now I'm trying to get this n by itself, so I would multiply the n up over here. And then that number is multiplying in to get n by itself, divide this over. to n needs to be bigger than whatever, excuse me, whatever this is. So I'm going to write that the other way so that it looks prettier to you guys. So n needs to be bigger than or equal to this number right here. Okay, so let's throw that in the calculator. Now we're going to have to be really careful here. Typing this out. 0.5 times 0.5. Let me put even the top in parentheses, even though I don't actually need them here. I just wanted to throw in, make sure I have enough parentheses. Divided by, I need parentheses here, and I'm going to need that entire bottom squared. So 0.03 divided by 1.96 squared. And we get that. So that says n is greater than or equal to 1067 point, I think it was 1 something or other. 1. So n has to be bigger than this. N has to be a whole number here, and we can't just use normal rounding rules. Up here when we had that issue with x, we just use normal rounding rules. This is different. N has to be bigger than 1067.11, and you can't have 0.11 people. We have to round up here because it says bigger than. So we have, no matter what decimal was here, we have to round up. So n must be at least 1068 to make sure the margin of error is less than or equal to 3%.